Hi class, we are now on chapter 2.5, the basic units of measurement. So I'm going to keep showing this table so you get familiar and understanding what units we are using in chemistry. So volume, liter, cubic meter, length, meter, SI units are meter, mass is grams, and temperature Celsius. Eventually we'll move on to Kelvin for gases, and time is seconds. Here are SI units. Meter is an M, kilogram is kg, seconds is S, and Kelvin is a capital K. All of these we will start using. You become very familiar with these the more and more we use them. So for length, we use meter or centimeter. We'll also use other ones, but mainly as you're learning this, it's meter or centimeter. 1 meter, one meter stick is 100 centimeters, so it's broken into 100 centimeters. 1 meter is equal to 39.4 inches. 1 meter is equal to 1.09 yards. And if you're looking at centimeters, centimeters is 2.54 centimeters equals 1 inch. This number, however, here is the only number. These are two different systems, numbering systems. This is metric, and this is what we use. Call it imperial units. This is actually an exact number. Now, remember, exact numbers do not count for sig figs if they are in the same value system. So if it's metric, for instance, 1 meter equals 100 centimeters, this do not count into sig figs. This is the only one that crosses over into two systems that is exact. We would not use this to count sig figs. And as we start doing more calculations, this will make sense. It'll come up again. Here's just some extra information to determine how they got this. But for length, we use meter or centimeters. For mass, we do not use weight, we use mass. Now the difference is, excuse me, the difference is that you weigh a certain amount on Earth. You go to the moon, you go to another planet, you weigh a different amount on that planet, and that is based on the gravitational pull on that planet. You weigh a certain amount on Earth based on the gravitational pull that Earth has on you. If you go to the moon, you do not have that same gravitational pull, so you can jump further, you can do all this stuff, and that's because of the gravitational pull. Now, we use mass. Sometimes you'll see the word weight, but we really mean mass, and we just use it interchangeably, but the understanding is it's mass, it's not weight. Mass will be the same regardless if you're on Earth or if you're on Mars. Think of mass is the best way I can put it is how thick you are. That thickness will not go away no matter if you're on Earth or you're on the moon. You'll still have the same amount of thickness. You're not going to automatically, if you're really skinny, get really thick. And if you're really, more, you're not going to immediately be less. You're going to stay that same. The best way I can say it is thickness. That mass will always stay the same regardless of where you're at. So that's why we use mass. Sometimes people get lazy and say weight, but we really mean mass. So just make sure that you understand that that's what it means. Mass has nothing to do with the gravitational pull. It's how thick you are. Basic unit is mass. That's what we tend to use. And for the SI unit, it's kilograms, but honestly, we'll tend to be using grams and different versions of grams. Volume is liter or milliliter, and 1 liter equals 1,000 milliliters. 1 liter is also equal to 1.06 quarts. 946 milliliters equals 1 quart. So none of this is equivalent to another value system, and we have to adjust for those issues. Again, here's that table. I'm trying to throw it in your face as much as possible so you can start getting very familiar with what is volume, what is the units for volume, what is the units for length, what is the units for mass, temperature, and time. Now we're going to get into a part that, again, students struggle with. These are prefix unit multipliers. What that means is you start with a base unit. The base unit in this case might be grams. So you see here, this goes from 10 to 0.1. So this is actually would have a 1. This would be the base unit. And then you use multipliers to either get a very large number or a very small number. And you have to learn how to do conversions in order to do that. And I think I have here another chart that might make this easier to understand. But here we do USDA Food and Drug Administration uses metric prefixes to express amounts of daily nutrient requirements. So even though we don't really use the metric system, we actually do use the metric system. You ever heard of a 5K? And if hopefully most of you are over 21, and if you have drank wine, it is in the metric system. You'll see, pull up a bottle of wine and it'll say 750 milliliters. It's thrown in, we just don't pay attention that the metric system is used in certain ways. So protein 50 grams, vitamin C 60 milligrams, vitamin B12 6 micrograms, calcium 1000 milligrams, and so forth. So we do have this around, we just don't pay attention. So prefixes, they are special feature to help you either make a unit larger or make a unit smaller, but we keep with the same base. So for instance, if we have grams as our base, then we can go into a larger number as kilograms, or we can go into a smaller number as milligrams. And you would have to use the prefix in order to adjust for that. So here is, excuse me, so milligrams is mg, micrograms is this kind of P with this cut off, or what other people do if they don't know how to use a symbol, you can use a U here and it means the same thing. A U with a G is micrograms, or you put mcg. This doesn't tend to be used that often, and I strongly don't recommend it. I would find the symbol here or use a UG, and that would be micrograms. So here is a base unit. 1 meter equals 1 meter. 1 gram, that should be gram, equals 1 gram. But if I wanted to make the number larger, I would need to use a prefix that is larger. So for instance, kilometer is 1,000. So that means that if I want 1,000 meters, I would actually have to use that kilometer in front to go from 1 meter to 1,000 meters. 1 kilogram equals 1,000 grams. 1 kilometer equals 1,000 meters. If none of this is making sense, hopefully as I go on, it will. And eventually we'll start doing a lot of math. You won't get away from this. So choose the prefix multiplier that is most convenient for a particular measurement. So you want to also pick something that works. You don't want something that has a ridiculous amount of zeros on either side. You want something that makes it as small as possible, but enough that it's workable. So a short chemical bond is about 1.2 times 10 to the negative 10 meters. This is a very, very, very small value. Which prefix multiplier should you use? So you don't want to have all these zeros. This is 1 times 2, and you'd have to write all these zeros out if you wanted. You want to work with something that you know is a small unit, but you can actually use it with not that many zeros. And so you want to pick a certain unit that's going to allow it. So if we were to look here, we want to see something that would allow us to do that. And so we look, we have pico, which is 10 times negative 12, or we have nano, which is 10 times negative 9. And we want to use it instead of this number here. So the best one that we could use here would be pico. Pico, because it would make us 120 picometers instead of keep saying 1.2 times 10 to the negative 10 meters. This is a number that is much easier to use if we're constantly doing calculations. And again, I'm just going to keep throwing these things out here so you can see them. There's a printout. The printout that I strongly suggest you guys all use for all your homework, your exams, and everything has this in it as well. And I'm going to show you guys how to read this stuff. So these are large prefixes. We don't tend to use these too often. Kilo tends to be the largest that we use, but you should know what these are. You know, if you see tera, terabytes, this is where some of this stuff comes. Giga, this is where some of this comes from. So deci, centi. So how you use this is where some of the confusion comes from. Centi, when you write it out, is 0.01. That's what this means. It goes into the hundredths place. It's 10 times negative 2. But if you have to use it to convert, you have to know how to use it. So 1 centimeter, one tiny little centimeter, is equal to 1 times 10 to the negative 2 meters. Why do you do it this way? Because 1 centimeter is very tiny and a meter is very large. So you have to show that the meter is not a full meter you're using, but just a little sliver of the meter, and that's where this comes in. But if you wanted to set it up with 1 meter, you could, but you also need to make an adjustment for it and show that 1 meter equals 100 centimeters. So depending on how you write this out, could affect your value, your answers, and how many zeros you have in the end. This is similar to, let's look at this one, and then I'll give you an example that hopefully makes you understand this. So milli goes to the thousandths place. That's 10 to the negative 3. So milli is a prefix. Whatever this would be milligrams, milliliters, millimeters. That's why I'm going over the base units so you understand what these are. Now, 1 millisecond, this is in seconds, S. 1 millisecond, remember, it's a tiny, tiny thing, and think of a big ruler. It's a tiny, tiny, even though it's not, this is time, but I'm trying to give a visual. You're taking a tiny, tiny little line in that ruler, but you have to show that the whole ruler exists. So 1 millisecond is equal to 1 times 10 to the negative 3 seconds. That's where you use this. But let's say you don't want to use this one. You want to use just the 1 second. So if you want to use 1 second, then you have to show that you're actually equivalent to 1 times 10 to the 3 milliseconds. So you have to show that this number here is larger than what you're using here. This is kind of, if this makes sense, it's kind of equivalent to 1 nickel. 1 nickel equals 5 pennies. You need more pennies to show that it's equivalent to the larger unit, if that makes sense. That's what I'm trying to show you. 1 nickel equals 5 pennies. If it's a smaller value, you're going to need more of it to show that that is equivalent to the larger value. And again, I found this one online. This is the base unit. 10 times 0, remember this is just 1. And then it starts going up with prefixes and then down with smaller prefixes. And it shows you how to use it. You use it 1 times 10 to 9 and so forth. So this is very good to have. Okay, so let's do some examples to show you. So 1,000 meters equals 1 blank meter. Now, you may not understand how to read this one yet, so I would use this one. So you have 1,000 meters. So if you go to this one, look for 1,000 meters right here. That's 1 kilometer. So 1 kilometer, 1 kilometer, 10 times 3 means 1,000. So this is 1,000 meters equals 1 kilometer. And then here's the conversion, which is equivalent. 1 times 10 to the negative 3 grams. So what is equivalent to that? So again, let's go back to this one. This one here is, I wrote it out so you can see what it actually looks like. So if we go to here, we can look for 0.0, here it is, milli. It's 1 millimeter equals, now remember, meter is just a base a unit. It could be milligrams, it could be milliliters, it could be all of that. But it's 0.001, and you can see it's 1 over 1,000ths, and you see all the information with it. So this is going to be 1 times 10 to the negative 3 is milli, or it's 1 times 10 to the negative 3 grams equals 1 milligram, or it's 0.001 gram equals 1 milligram. And now we have a last one. This is 0.01 milli, and let's go back up. We have centimeters. It is 1 centimeter. That's what this means. If you plug this into your calculator, this is what should come up. And if you have problems with it, just do 1 times 10 and then do the exponent -2, and that's what you'll see is this comes up. So if you do that, then you see the prefix is 0.01 centi, and you see the conversion for it. Okay, so which is larger, 1 milligram or 1 megagram? And the base is gram. So here is mega, and here is milli. Remember, when it's negative numbers, they're not negative numbers. They are less than 1. That's all it means. It's less than 1, and it's many, either a lot of zeros away from the, the ones place or the tenths place, or it's not. So that's what these mean. So I spelled these out for you so you can wrote them out so you can see the differences. So of course, megagrams is much larger than milligrams. And that would be dangerous. You never want to be given something in megagrams when it's milligrams. It would kill you. All right, so derived units. A derived unit is a unit that is formed from other units. So let's first understand this. Let's look at something like length. If you measure something with the ruler, we're not using the inches side anymore. We're going to flip it over and you're going to use centimeters. Centimeters to measure a book. And you want to do just one side of the book. That's length. But if you multiply the length times the width, you now have area. You have 2 dimensions. And that's centimeters times centimeters, so this would be centimeters squared. But if you go further, one more, and you do length, width, and height, think of a shoebox, you now have volume because you have depth as well. So area would be You're going to put flooring in a room. Volume is a shoebox. You're trying to figure out how big the shoebox is. And a length is measuring just, from where you're standing to the end of a room. So these are derived units. And you can see here that 1 meter times 1 meter times 1 meter will give you meters cubed, because you're times this, times that, which is very similar to what I'm showing you here. These are just larger units. This is a base unit, where this is a smaller number that you're using. And you can actually start doing conversions to change them down. Now, what this thing is showing you here is that there are some units that you can actually cross over. So 1 centimeter cubed is actually equal to 1 milliliter, and that will come up in as we start going on, because you'll have to start converting. And this is a very important unit to know, is 1 centimeter cubed equals 1 milliliters. We don't tend to use this one as much, but we definitely use this one a lot. And so if you wanted to even expand it up, 1 centimeter, you could actually make this to 1,000 centimeters equals 1,000 milliliters. 1,000 milliliters actually equals a liter. So these are the only units that 1 centimeter by itself is length, but as you start making it, multiplying it by itself 3 times, it's now volume. And then you can get into volume away from length. Because remember, length and volume are not the same thing. Okay, so identify the larger unit in the following. So the base unit is meter, so is millimeter or centimeter larger? Now, let's take a look at this chart. The more larger this number is, the further away it is from 1, just number 1. Because once you start getting to negative numbers here, that means that they are on the other side of the decimal point. And the more numbers there are, the further it is away, the smaller that number is. Just like if you go this way, this is a larger number compared to what you have right here. So I think I have this all, yeah. Okay, so we have a millimeter, which is 0.01 meters. It is smaller than centimeter, because millimeter is 10 to negative 3, but centimeter is 10 to negative 2. It's closer to 1. You want to get it right here. Kilogram or centigram. A kilogram is 1,000 grams, and a centigram is down here. So of course, kilogram is going to be higher. There's not a negative number. That's the first kind of hint right here on the exponent. Now we have millimeter or microliter. A milliliter is 0.001 liters. And again, any of these numbers, just plug them into your calculator, they will show up in the decimal form. Larger than a microliter. So you can see it's a very, very small number compared to this number. And a kiloliter is 1,000 liters. And we're looking at a microliter, which is, again, a very small number. So this is a large number compared to this number. And negatives do not mean negative numbers. They mean they're less than 0, but they're further and further away from 1. I mean, they're less than 1. Sorry. That's it.